Hello, welcome to my course project, Electric Circuit Theory. My name is Mia Reponte from BS Computer Engineering. I'm going to talk about what is Kirchoff law and its function. But before that, we're going to um, know the circuits and the tools on how to use it from the Ohm's law. And this is what we're going to talk about. So understanding the circuit. So what is resistor and what is the voltage and what is the other circuit like parallel and series. So the resistor, this is the actual resistor as you can see, and this is the resistor symbol that we all commonly use when we're going to compute or to study about it and or discuss it on in the lesson and the discussion that we had. And this is the actual resistor that we're going to use in the circuits in electric. And this is the battery. As you can see, there is a direction of electron flow coming into the battery and coming out to the battery that have the positive and the negative. The positive is that's what the electron flow going into the battery and coming out from battery is also negative. So we have a parallel circuit here that have you use. It's like you're using a Google map and you have the different road. That's how I analyze the parallel circuit. Especially this our lesson is not much easy easier for me to understand. So I do research about it to understand and to apply. Especially I'm learning and I have my lessons here and understanding the course project that I have also. And also understanding it because once we apply it in actual field, this is very helpful. And we should not ignore that only study because you have these lessons in your course. You just only study it and you don't understand or analyze what is the use of this part of the circuits that we had. So it's very helpful to study. I recommend that. So we're going back to our topic. The parallel circuits is just like it's like a house that you have a different circuit that it's used for not to affect the other bulbs and the other resistor, because once you use the parallel circuit, if the other resistors affect, then the other part of the resistor, the other one resistor is not going to uh, off the bulb when it functions. So in the series circuit, once that you use it alone, if there is something interrupt on the wire of the circuit, then everything is turned off. While the parallel circuit is just you will use this one when you're not interrupting other circuit. So mostly it's used in the house, and this one is used. I don't know yet, but it's very helpful and it's very direct. And when you are studying this one. So, just like I said here, we have a series and parallel, and the series is this is the formula from voltage, current, and resistance. So in a series, we have voltage in is equals to voltage 1 plus voltage 2 plus voltage 3. The difference of parallel formula in voltage, the voltage in is equals to voltage 2 is equals to voltage 3. As you can see, why is different because here they have only one path, so it's straight. When you just like you're going to your destinations, it's like you're going to straight and you don't have to go to a different route. So that's why it's add. While this one in parallel, you have what is coming out from your voltage battery that's also in the voltage 2 and voltage 3. So in current, we have a series is equals to current 1 is equals to current 2 and equals to current 3 because this is connected together, and that's why it are all direct to equal. While here in parallel, as you can see, you have a parallel current in is equals to current 1 plus current 2 plus current 3, so they added up together, so we can find the current, the total current. In resistance, in a series, we have resistance equation is equals to resistance 1 plus resistance 2 plus resistance 3, because as you can see, they already have direct destination to to once you get in the circuit, you get out the same way, and it's easy. Not like in parallel, you have to go through um, connecting parallel circuit. So we have 1 over resistance equation is equals to 1 over resistance 1 plus 1 over resistance 2 plus 1 resistance over 3. So, like I said on the first part, that if we use the series, uh, like this one is the features that if one of the components burn, the current becomes inactive because it's direct. While here is parallel, if one of component burns, current stops only through the branch rests apart. Works fine. If your current stops on resistor 1 and it didn't work your bulb, but the other part, resistor 2, resistor 3 is still working. Only resistor 1 is stopped and it's not working the bulb. So now we're going to talk the history and how the Kirchoff's law began. So Gustav Robert Kirchoff, born on March 12, 1824, in Kaliningrad, Russia, he wrote the laws of closed electric circuits in 1845 and died in October 1887 in Berlin, Germany. So Kirchhoff's first research topic was on the conduction of electricity. As a result of his research, he wrote the laws of closed electric circuits in 1845. This law was named after their author, which are now known as Kirchhoff current and voltage laws. These laws apply to electric circuits and the studies to electric engineering, and it's combined to my course, which is computer engineering. So now we're going to understand what is the two types of Kirchhoff law. So first we have Kirchhoff's current law, or KCL, that states that the algebraic sum of all currents entering and exiting a node must equal to 0. Also, we have to understand what is the junctions and its functions of the circuits. So here we have junctions, and junction is like a point where your current starting to entering the circuit. And here we have current 1 just started to entering the circuit and going to the other directions and continuing to straight to the other directions too. And we have the current in, and it is equals to current out. And that's the formula is I1 is equals to I2 plus I3. And here is the node and a branch of loop and a mesh. So node is like a point where a two or more circuit elements join. You can see here we have the variable, that's the node. And a mesh is a voltage sum. It's a loop that does not enclose any other loops. And a branch is a circuit path that contains two nodes. So loop, a path which starting node is equals to last node can contain many meshes. In junction rule, the sum of magnitudes of the current directed into junctions equals to the sum of the magnitudes of the current directed out of the junction. So Kirchhoff current law is when you use the circuit, they depend on the voltage that you use. So if you use the voltage that low, very low, once they trouble the current on the circuit, then the bulb is either high, getting a brighter, or a low bright because of the voltage that you have. If you have a voltage higher, then you your bulb is going to work on higher too. But if the voltage is very low, then your bulb is not working much, getting a brighter like we want to have, especially when you're working at home and having assignments and we need a bulb lighter, so we have to use the voltage in our home higher. It's depend because current is depend on the voltage in this law, in the Kirchhoff current law. So in Kirchhoff's voltage law, or KVL, it states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also equal to zero. In other words, the algebraic sum of all voltages within the loop must be equal to zero. For short, if there is like 10 volts going into your circuit, then the 10 volts coming out from the circuit is also the same. So the positive and negative is same of the voltage that you have getting in and out to your circuit. So we have loop here on a chart. It shows that this is your guide. This is guide, but in actual circuit you cannot see this loop. It's just a help for us to understand and how to compute the circuits. So compute solve the problems of the circuit. And I'm very confused how to work this one because I, I don't know how to work on it, to be honest, without studying and analyzing how it works. So it's better to study. Like I said, it's better to study and analyze it, and having more time to understand the lessons, and it's very helpful once you apply it in a field. So here we have Kirchhoff circuit laws formula, Kirchhoff circuit laws, and as you can see, this is a positive sign here and a negative sign. So once, if you started to entered here, you have, or leaving here, you have a negative. But once you entered in the circuit, you have a positive sign. But once you come here, and it showed that you're leaving on the circuit, this is negative. And this one is this one. So in Kirchhoff current law, they're focusing on what is the current in and out. And this is the formula, I1 is equal to I2 plus I3. While in Kirchhoff voltage law, or KVL, they only focusing on voltage coming in and out. So if there is problem solving, they combine it together once you know each of the law, and you will not have a difficult to understand it. But once you don't analyze it one by one, they're giving you a confusion. So now I have a problem solving with solution in KCL, Kirchhoff's current law. So I got the circuit here, example, and I got current 1 is equals positive 10 ampere, and we have current 2 is equals to negative 4A because it's leaving. and I3, that's the unknown. That's what I'm going to find. So we have the sum of I is equal to 0, and we use the formula that we discussed already. It's current in and out, which is I1 plus I2 plus I3 is equal to 0. So we have the positive ampere current, so we're going to use this one, and minus the 4A because it's leaving, plus I3 is equal to 0. 6A plus I3 is equal to 0, so we have I3 is equal to negative 6A, which is ampere. So if you use, you find the current, so you have to label it ampere. So if you find voltage, you have to put it on voltage sign also. So why is negative 6A? It's not negative 6A because you only have here, there is no negative sign. We have to transfer the 6 ampere to find the current tree, and this is how it works the equations. So that's why you put the negative 6 here. But if you have negative already on your, like this one, you have negative, then we have positive once you transfer it on another side. So here we have a trivial example problem and solution. So I use every circuit to to um, to show you the value of each side of the voltage and the ampere and the current going in and out of the circuit. So we have the formula plus V, voltage 1V1. So I started my node here, B1, P1 is here, and we have B2 is here. So B1 is my voltage, which is 12 volts, and my B2 is 8 volts. So we have positive 12 volts minus 50 current I plus 8 is equals to 30 I is equals to 0. 20 minus 80 I is equals to 0. And we have 20. So if you confuse where is 20 coming from, I add the two value of a voltage because they don't have a variable, but still you have the same variable you have to add. It depends on the sign. If the sign is both negative and negative, you have to add it together, and if we have the both the same sign, you have to add. That's how it works on this equation. So I add 12 plus 8 is equals to 20, and I add the current side is equals to 80. So now we have 20. 20 minus 80 I is equals to 0. So we have to find the value of current. So I'm transfer the one who have the variable the other side, so it became positive. So now we have to cancel the side of the current value and put it divide also to the number that left. So this is the result of current. So 20 divided 80, we have 0.25 current. So you're wondering why does it's 0.25, and it showed here in every circuit have negative 500 millivolts. I converted it, and here they don't convert, they use millivolts. So this one we have the volts directly, so you have to, I converted it to millivolts to volts, so this is the result. So now we have the current value, going to find the voltage 1 on the resistor 1. So we have 0.25 A times 50 is equals to voltage 1 is equals to 12.5. And then the same formula, but now we apply how the branch connected together, uh, like in the middle, point to point. So we have VC minus VB is equals to I, is equals to negative I R1. VC is equals to VB minus I R1 is equals to 12. The value of second volts is, the value of first volts is equals to 12 minus 0.25 times the 50, and we have VC is equals to negative 0.5 V volts. So you can see here, to find the C point here, you have negative 0.5 plus 8 is equal to 7.5 volts. This one. And now for the resistor 2, we have VA minus VD is equals to I, negative I R2, because VA is equals VD is equals negative minus I R2, and VA is equal to 7.5 minus 0.25 times 30 ohms, and we have in a total of 0 volts in VA, as you can see here. So once we study this part of Kirchoff's law, and it's very important, and it's wonderful to understand each of the lesson, because it's connected to every lesson and why it's going to happen. Cannot jump to understand directly, so you by step, and that's what I analyze while I'm solving the laboratories and answering the questions of this subject, and I'm glad I do it actual on my own research and understanding also. So that's all my course project in electric circuit theory 1. Thank you for watching, and have a good day.